So homework question 34 is really a challenging question, right? It's asking you the pH of this 0.045 molar solution of potassium fluoride. And what makes this tricky is that, where do we start? Potassium fluoride doesn't exactly look like an acid. It's not an acid. But what we want to focus on is this fluoride. Fluoride is the conjugate base of hydrofluoric acid. And that's what's important for this reaction and this problem, is that hydrofluoric acid is a weak acid, which means that fluoride will behave like a base. There is an equilibrium here between HF and fluoride. So because we have an equilibrium, because this goes back and forth, HF acts like an acid, a weak acid, but that also makes fluoride, right, a conjugate base. So fluoride on its own will behave like a base. And so this is how a buffer would work, right? A buffer works because you have a weak acid and its conjugate base present, right? You've got something that can react with both species in an acid-base reaction. So we want to focus on the fluoride. Fluoride, we add that to solution, and fluoride behaves like a base. So if I add fluoride to solution, right, because fluoride is the conjugate base of a weak acid, it behaves like a base. It'll reform some HF, and will form, right, some hydroxide in that equilibrium. So our KB for that would be, all right, the concentration, HF, hydroxide, all over the concentration of our fluoride. And we're going to have to start here because we know fluoride concentration. They tell us the fluoride concentration in potassium fluoride. I don't know the HF concentration. I don't know the hydroxide concentration. That's what we're going to have to find. We don't know where that equilibrium is. So we have to start with the KB. So, correct, it's potassium fluoride, but the reason why this is important is that the potassium is the conjugate base, right, of HF, right? Potassium fluoride, not an acid, right? HF is. So this is why we're talking about HF, is because fluoride behaves like a base. So we have to get the KB, right? So I would start there, right? Ka times Kb equals Kw, 1 times 10 to the minus 14. So, right, Kb equals 1 times 10 to the minus 14 divided by 7.2 times 10 to the minus 4 Kb. So they could have made this problem easier for you by just giving you the Kb or giving you the Ka. All right, 1 times 10 to the minus 14 divided by 7.2 times 10 to the minus 4. And we get a KB of 1.39 times 10 to the minus 11. A really small KB. So it's a really weak base, but fluoride is a base. It does behave like a base. Now we can use our KB. So I know 1.39 times 10 to the minus 11 equals, right, X times X all over my 0.045 concentration, right? So the concentration of potassium fluoride is a strong electrolyte that ionizes completely. So that's going to equal my concentration of fluoride. So we can plug in the 0.045 down here. I just talked about how we don't know HF concentration. We don't know hydroxide concentration, but for every fluoride that reacts, we're going to get 1 HF and 1 hydroxide. So it's a 1-to-1. So we can call both of them X, and then we can have an equation we can solve. All right. So I multiply across by 0.045. I get X squared equals 6.25 times 10 to the minus 13. Square root of both sides. And I get x equals 7.905 times 10 to the minus 7. What is x? Right? X is our hydroxide concentration. So we want to find pH. So we've got a couple different pathways we can take from here. Right, that would have been step 2. So step 3, we'll go back to red. Step 3, right, we've got our hydroxide concentration. So I would say we can find the POH and then we can find the pH from that. 7.905, 10 to the minus 7. So POH equals the negative log of 7.905, 10 to the minus 7. It's going to be pretty close to a neutral pH, right? We're pretty close to 7. Negative log. I get a POH of 6.10. All right, so our last step to find the pH, we know pH plus POH equals 14. So my pH equals 14 minus 6.10. Right, my pH is going to equal, 7.90 for my pH. So this is all because it's potassium fluoride and fluoride. Right, I know we started with potassium fluoride, but we have to recognize that fluoride is the conjugate base of a weak acid, right? It's the conjugate base of HF. Because HF is a weak acid, there's an equilibrium here, and that means fluoride is a weak base. We couldn't do the same problem if they gave us like sodium chloride, right? For sodium chloride, this wouldn't be a calculation. This wouldn't be a problem because sodium chloride is the conjugate base of a strong acid, HCl. And because HCl is a strong acid, there is no equilibrium, right? It would be hydronium and chloride. Because there's no equilibrium, because HCl is a strong acid, this just goes one direction, right? This just ionizes completely. Because there's no reversibility, chloride, right, doesn't behave like a base. So it's only the fact that this is the conjugate base of a weak acid that makes this behave like a base. This only applies to the conjugate bases, right? This of weak acids. That when we add to solution, they would change the pH of the solution.